Hello, and welcome to Swarm Community Call, a monthly call for developers, node operators, and the wider community around Swarm, happening every last Thursday of the month, broadcast to X, to YouTube, and soon coming to Swarm as well. If you'd like to ask a question during the call or later, please just head to Swarm's Discord server and use stage chat to post your questions. I'll be picking them up there. In today's July's call, we will start with core development updates as we usually do, and then continue straight on to community talk, where we'll welcome MFW78, developer of Vertex, which is an independent implementation of a Swarm node written in Rust. All right, that's on the agenda. Let's kick things off. First, course development updates. Since our last community call in June, a B2.8.1 has been released, and there's already new items in progress. Elat is here with us to lay out some details. Elat, please.
Thank you, Mina. Since the last release, we've been actually working on quite a lot of improvements. So I'm not going to touch upon what was actually released already, but touch upon everything that we've been working since. First thing is the protocol improvements. So we have some small changes that we're about to merge into the code base, which are related to the Hive protocol. So we're making all of the address discovery process to be more efficient and less verbose, with less kind of small inefficient messages. So that's inbound. We have part of the team working on some hardening and improvements of the pulsing protocol that allows us to basically harden the protocol more and to have better syncing. So that's also work in progress. We've had also some brought to our attention also some areas in the code base that need more hardening, so we're working on that. There's quite a lot of inbound fixes also supposed to come in the next week or two that will harden quite a bit of packages. And with that also, we are working on building internal frameworks that would help us to maintain this level of scrutiny over the hardening of the individual components. So that's also being shipped. Otherwise, another part of the team is working on improving our simulations, which are also related to the actual protocols and syncing edge cases that we're trying to find and harden. So we're working on tooling, which is reusing our existing tooling. We're also writing new tools to actually allow us to have a better visualization of and better metrics on what's going on when the network experiences all sorts of different kind of a parameter or consensus parameter drifts, like during normal operation. So that's also something that will allow us to improve the protocol in the future, and also have better integration testing in the future to basically be able to reproduce scenarios more easily and have more intricate scenarios that can give better guarantees and better assurances about the code that we're actually shipping and changes that we want to ship in the future. That's also very important. We have quite a bit of initiatives and kind of ongoing tasks relating to protocol improvements relating to streaming. So that's also something that we're working on. I won't go into much detail here, but we're on it and we're full steam ahead with this. We're full stream ahead with this. And there is also a very important part that we're also working on, which is the backwards compatibility support, which would allow us to basically support multiple protocol versions between nodes. So the idea is that once we have a version update, for example, so in many cases when we actually change the protocols, so we have to bump the actual protocol version. So usually what this means is that older nodes can talk to new nodes. I mean, sometimes we actually have to do an actual breaking change, which is something which we don't have that much in the actual, for example, handshake protocol, and then you actually get a real split in the network. But we're working on machinery and plumbing that would allow us to, in case we don't have these kind of rare cases where we actually have to split the network, then that we can support multiple different version handlers for the same protocol. And so different, like, newer nodes can talk to older nodes, and older nodes can talk to newer nodes, and we can kind of have better phasing out of both kind of like deprecation of protocol of older protocols, yeah, kind of like making basically like these kind of rolling updates to be more friction free, let's say, or more, yeah, easier to roll out, easier to reason about also, and have better kind of guarantees it all around the network, all across the board with different metrics and so on. So this is also something that we're going to ship very soon. And yeah, I think that's kind of it. So I don't know if you have any questions. If not, then
I'm not seeing any questions on Discord, but if later on one pops up, please stay with us a bit longer. But thank you for this thorough report. I am seeing in Stage Chat reporting that, yeah, the X broadcasts seems to not be working today, which means, yeah, I hope that people are switching to YouTube. But let's just continue and invite Callum to the stage now to cover research updates.
Hello, Mina. Can you hear me okay?
Yes, I can.
Perfect. Well, hello, everybody. On the research side of things, where to begin? So really, since the dawn of Fable, a lot of our work and all of our efforts have rapidly improved, increased velocity, but also the volume of work and material that we're working with in the research team has expanded sort of exponentially. So really the main thing that we've been doing currently is reorganizing ourselves for our SWIP processes, document processes, the prioritization of those documents, how they get worked on and digested so that we can actually reach conclusions and actionable intel that we can move forward with in every item on our roadmap. What is that actually included as of late and forced us to reprioritize and reshuffle? So we were previously more so focusing on our tokenomics roadmap, the features on that, withdrawable stake, and through all of our efforts and documentation and what we've been doing with the likes of AI and just deeper research is then in the shorter term, prioritize different items such as phase 5, which is handling some of the edge cases around the incentives, around the redistribution game, as well as ACT and making optimizations around it, which is really critical for our big, key, incredible use case, which is just streaming on Swarm at scale. And so a lot of our efforts have been more geared towards and reprioritized towards these efforts, putting our tokenomics feature roadmap on the back foot, but not to say that work isn't being done, because one of our other critical items that we've all been heavily working on is around price predictability initiatives. So a lot of those SWIPs and a lot of items on that roadmap involve things like data availability that is handled through basically insurance markets or insurance contracts, the idea around fixed pricing subscriptions for stamps as well, and that may or may not include Oracle optimizations, and really everything's on the table on how we piece these things together, write these up, and then make decisions on them. So if anything, the recent reprioritization of our items has given us a huge amount of room to think and build out a lot of these much larger, grander ideas that can make the entire network much more usable and much more interesting in so many ways. And then lastly, to top that off as well, I should say also then PulseLink has moved along nicely from out of the research team and into development as well, as sort of Elad was saying earlier. And then the last thing that we're really concerned with and talking about, and it's also been in our Discord as well, which I would like to invite everybody to continue to talk about and give more feedback and give more information about what the pros and cons might be, what everyone would sort of lean towards, is this idea of Swarm and Homecoming and migrating to ETH mainnet, especially recently with the dawn of the EEZ, or the Ethereum Economic Zone, proves for very, very interesting changes and decisions and initiatives that we can make at Swarm that we're already speaking about internally, we're already speaking about on Discord. And yes, I would just like to invite everybody to add whatever comments you have in that initiative, because it's not ironed out completely just yet, and we'd like to hear from everybody and anybody in the community. But overall, I'd say a lot of material is coming out, a lot of changes are being worked on at a very, very high level, and excited to see what happens here for the second half of the year, basically, from the research team.
Indeed, thanks, Callum, for this thorough report. In Discord, we have several channels. There you can please find some of these topics that Callum just mentioned in separate channels. But if you're confused and don't know where to start, just go to Orange Lounge and we'll take you from there. So yes, absolutely, every feedback more than welcome. And this debate around potential ETHCOM coming is a hot one. So do get in, do share your views. We would like to hear your opinions on that. One of people that is also already expressed their opinion is MFW, who we're also having in the call today, not to actually discuss that, but rather for him to present Vertex, which is an independent implementation of a Swarm node written in Rust, as I mentioned in the beginning. So I hope we can get MFW78 on stage.
Hi.
Oh yeah, you're here. You're here.
Yep.
So rather than
And-
building on the existing B code base, it's been decided that this is going to be a clean sheet implementation that speaks the same network protocol, and it is obviously designed to interoperate with the live Swarm network, but it's coming at building the client from a different perspective. So I'm gonna let you explain what that was. So what are the choices or drivers behind this different approach that you took?
Sure. Thanks, Mina. Thanks for the introduction. And yes, it's up. I can see the screen sharing. Great. Okay, so people in the community may have heard of me before, but I'm the developer behind Vertex, which is what I'm hoping to be able to use in some embedded projects across like multiple devices and architectures and these kind of things. So this implementation, Vertex it initially started as some work that I did on swarming Wikipedia approximately 3 years ago, when we published Wikipedia through to Swarm. And the implementation ended up being able to push the entire 100 gigabytes Wikipedia through to Swarm within 2 days using just commodity grade hardware. So the power of a systems language was definitely helpful with being able to handle all that data. So it's been something in the process for a while. But in the network here on Swarm, currently just did some recent look around, and there's around about 3,900 nodes in the network. And those 3,900 are all running B. So they're running a single client. So this section, we touch a bit on why we need to have some diversity. So there have been historically some events that have happened in Ethereum mainnets due to a majority client shares causing issues in the network stability. And so this is why the Ethereum Foundation, as an example, has placed a significant priority on client diversification. And also why I feel that if I want to be able to also run for developing applications myself, I think that we in Swarm should also be championing client diversity so that we ensure that the network is robust and resilient, so we don't have similar bad days.
Indeed.
So there's some slight differences with the way failure cases happen between Ethereum and Swarm. Most of the time related to the fact that we are in a single client. So, for example, like in the redistribution game, the economics and the design is quite good at detecting liars, but if all the clients that are playing have a bug, how does one detect who is lying? So we can skip through that one. So essentially what Vertex is Vertex is the node implementation I've been working on, but it's become a quite a bit bigger than that, in that unlike the B code base, which has all the primitives that that Swarm uses within the same repository, I take a particularly opinionated approach of stripping out the primitives, and the primitives live in a repository called Nectar. And that's where we have like all the types for, chunks and proofs, BMT, etc. There is heavy work happening in Nectar at the moment. A lot around optimization, a lot around developer experience to make sure that, like idiomatic tooling is there in Rust for like Rust builders. Heavy type stating, using the Rust type system to completely eliminate whole classes of runtime errors. And being like very particular on that to harden the primitives, because everything builds on top of it. And so Vertex builds on top of this. And so Vertex is a consumer of Nectar, and that's where all the protocols and protocol handling lives. And then Vertex is itself designed to essentially be embedded and provide up to, I think it's like 4 interfaces. So what it currently does at the moment, currently it is able to fetch and retrieve chunks from the network in a terminal environment, also in a browser environment. I've also been able to do it on an embedded device on a Kobo Ellipsa 2E, which I can't demo for you today, but I can demo the WASM. So like a Kobo Ellipsa is an e-reader. So, the idea being that like you can have Swarm as a backend for, say, an EPUB store or these kind of things. So at the moment, PoolSync is in alpha. There is some wiring there for it. And most of it at the moment for PushSync is also looking at, because it's like associated with the reserve development that I'm doing at the moment. So this stuff is in build. Yeah. So currently it's slated to become a full node, or in Vertex parlance, I break it down into boot nodes, which are just for topology discovery. Then you have clients, which they get and put data into Swarm. And then you have story nodes, it's a similar parlance as compared to B, but tries to like basically like encapsulate these boxes more rigidly. Okay, so next. That's where we're at the moment. Gateway, no proxy. Yeah, well, so this has kind of been done a bit. Like, there's been some demonstrations for this. This is to show that, like, Vertex as well is able to function in a browser, and so I should be able to just change tabs here. And so at the moment, unfortunately, I don't have the IP location data loaded, so you can't see these nodes all around the place that are connected to. But given that a sheer majority of the nodes are actually in Hetzner data centers in Germany and in Helsinki, you can just imagine that's where the 2 dots are. So we have here a reference of a BMT file, and we have a series of nodes that we're joined to. So this is in secure WebSockets. So connected to 108, and we can download. So this is like an approximately 800 megabyte file, and settles in. Usually, like for my location, latency, it usually settles in somewhere around about 600 kilobytes, give or take, on WASM within the browser. Okay, I haven't added a stop button in this. This is just to like demonstrate like the use of the WASM within the browser. Okay.
Very nice. Okay.
It needs some significant UX improvement on it.
Well, because I don't think I've seen this demonstration of the in-browser one.
Yeah, like one of the unique things to Vertex is it's also taken like quite an opinionated approach on how to treat peers, how to treat other Swarm nodes. And so it's built into the connection handling and built into the accounting associated with peers, into its peer store. It will do scoring of the peers. So you can see like as chunks are retrieved successfully by the nodes on the right-hand side, you can see some have their scores increasing, and or if there's like some protocol problem that comes about and the node determines that it's a fault of the so say for instance, like if a node accidentally served data to a Vertex node that was found to be invalid or corrupt, then this would be flagged as quite likely a protocol violation, and then the peer scoring would be adjusted accordingly. And then it gets down to like a certain level where we'll actually start to like actively ban malicious nodes and these kind of things. And that feeds into the accounting mechanism and into other mechanisms. So it's quite opinionated about how to so you can set like the parameters for it, but it does like keep account of how well behaving the peers are in its view. Okay, so yeah, this runs in Chrome and Firefox. So basically standard WASM. So now one of the other things that I'm doing with Vertex is, and this has been great with the recent changes in B, being able to support multiple addresses for dialing. I really want to push like different transports now. And so like if a client is capable of dialing a different transport, well then it can do so. And the aim is for Vertex out of the box to be able to support additionally web transport and WebRTC. And this will alleviate significantly for those that are able to speak those transports, which at this point would only be Vertex nodes, but would be happy to contribute to the B code base to try and push that along there for additional transports. Essentially to try and eliminate or significantly reduce the friction associated with setting up NAT forwarding or firewall rules, because if we want this to run on people's home computers or run at the edge, if anyone has to configure a router, this is just not, in my opinion, it's just not suitable. And so we can do various hole punching techniques, making use of WebRTC, and B already is supporting Quick, which is good. Yeah, this is just talking about better routability. And so now in regards to Vertex, so as I mentioned, Vertex is designed to essentially like serve a common API to being embedded. So it can be embedded as a Rust application. So this is what helps with the Kobo Ellipsa 2E, which it actually has an e-reader software which is written in Rust, so it's quite straightforward to embed. But it also has FFI surface, and it has the WASM, which we just saw, but unlike B, it does not serve HTTP. It only serves gRPC. And this was somewhat of an opinion taken to ensure, basically it gives easy typing across the RPC surface, so that on Vertex and on Vertex nodes and software that interacts with Vertex via gRPC, one doesn't get drift on, say, like open API standards you get otherwise on REST-based interfaces. So it's mostly just to ensure that the protocols for the API stay coherent. Okay. Now, also, like with Vertex, like when say, like, for example, like when it's compiled into a client, so one just wants to use it for download, it's already configured to be able to strip out all the redundant surface. So like no stories, nothing. So like you look at like significantly reduced binary size. So for example, like the WASM that we just saw, this has a significantly reduced binary size compared to a full storage node or a full node. Just a few stats. So on at the moment on in terminal, it's doing around about 950 kilobytes per second, which is getting towards the upper edge from what I'm led to believe on sudosettle. Some are pushing like a bit higher than that, like from some of the other node developers out there. Then other areas where I've been pushing is, like, say for example in the primitives. So this has been like one of the good things, like to be able to look at things, you know, from somewhat of a clean sheet and then compare and contrast. So for example, like with feeds, which are arguably may get more use as more utility is built upon Swarm, it can get to the point where the feed index is so long that it actually might start to run into issues, or the feed length is so long you might start to run into issues with the way that the feeds are currently processed within B. So for example, like, you know, if a feed is what this shows here, like if a feed is say 100,000 long, on Nectar, it will do around about 9 RTTs, or nine batches of RTTs. So everything in Vertex is streamed and runs multiple concurrent fetches. So one of the things, because operating like over Swarm, where like it can be somewhat latency sensitive, especially like if you're not currently co-located in Europe, and because of the concentration of Swarm nodes, this can lead to somewhat of poorish performance. So minimizing RTTs is quite, like round time trips, is quite critical to give like some semblance of motion to the use of, or the acquisition of data in Swarm. So this is why, like, I put heavy emphasis on reducing round trip times, or reducing rounds in general. So yeah, this is why I've been optimizing on this level as well. Now I noticed that, like, Elad was talking before about doing some work on the testing frameworks within B, which is awesome to hear. This is an area that I've also been working like quite heavily in that recently in Vertex, the entire node is now able to be essentially simulated. So this allows to reduce the time significantly to be able to run simulations in simulated environments. It's not quite at like full node yet, but it's able to essentially fake libp2p transports and inject latency, failures, network partitions, these kind of things in a simulated basis. And I'm hoping that this is like same point as Elad. I'm hoping that this enables to flesh out like some more performance, well, not performance necessary, but some better understanding of how the node operates in certain conditions. And one of the good things as well from this is that I essentially, by implementing this, and one of the reasons why it's somewhat slower than maybe some others out there is like I do take the time to like look through carefully in the B code base to see what it is that I am not understanding, and also to push where I say, for instance, I may see problems, and there have been a few issues that have been quietly disclosed through to the B keepers, so which has been helpful for network stability. So yeah, this is basically a second look at Swarm, and if you think they should exist, leave a star on the GitHub repository, and because this helps when like discussing things with foundations.
I think.
Sorry.
And hit subscribe button. No, I'm just joking. Actually, I'm browsing because this is really nice. I know that this page exists and everybody can take a look at it and like just walk slowly through it again. So I'm gonna fetch the link and I'm gonna post it in Discord channel. But yeah, do go on. Sorry to disturb you.
No, that's all.
Yeah, and it's gone. Okay, I wanted actually to ask you to scroll a little bit back on the start, because okay, some things are in progress, some things you say are already shipped, but some are in the design phase. So maybe you can also talk a little bit on what
Sure.
choices you're
Just
making,
one.
on, like thinking about design and kind of why. Maybe I think I saw Redistribution Game being in design phase. So
Sure.
how are you going about it?
So one that I've been looking at quite heavily, because so it is back here. So one that I've been looking at quite heavily at the moment, and this has been because of some bugs that I found in my own code when I started introducing like static testing and fuzz testing. I found some issues in my implementation of Manta Ray, and in doing so, I got thinking more about manifests, and this got me to the point where essentially to look at, instead of manifests specifically, like something like that's prefix path based, but to then move this to a key value store, but introducing certain additions to the nodes, such as the counts, so that then essentially you can then run like range-based queries, iterators, and these kind of things over a key value store. And essentially, like then the manifest that is what's used to like list files, as an example, becomes an expression on top of a key value store. But then what becomes very, very neat about the key value store is then, because it can be deterministic based upon the content that is constructed within, this can then be used for consensus, as an example. And so I am interested in areas whereby this could potentially be something that could work somewhat within like PoolSync. I have to like also like look at the work that's being done at the moment in PoolSync by the B team and the research team there, to see if that aligns, or if it conflicts, or if it's like, or if we like arrived at a similar solution. But in doing so, then, for example, like this allows, depending upon how one then determines the proof of possession of storage to participate in the redistribution game, this change in data structure may be able to significantly reduce the processing power required by the redistribution game, because one could nearly in effect provide similar economic guarantees with data availability sampling, and this manifest, and in doing so, reduce and or eliminate the hashing of all the chunks for the nodes that are participating in the redistribution game. And so in doing so, this, like, long story short, this enables more rapid participation in a redistribution game, or even rethinking, is a redistribution game necessary? And can this change itself to something whereby it can be a consistent state where all nodes participate in essentially continual consensus, ongoing, like every round, so that effectively they earn an APY as opposed to a probabilistic distribution. So like this is like, so like what starts with thinking about manta ray manifests ends in like redistribution games and consensus. So I think that this is like somewhat of a neatish solution, something that like I've been like spitballing around in my mind. I would be keen if that turns out to be maybe a more efficient, maybe a similarly efficient way of doing pool sync, to like running simulations on this kind of stuff and seeing if this has teeth. Because at the moment, like, pool sync, from my understanding, is a very tumultuous time for a node, and so if that can be smooth, it'd be great. And so this is like all the stuff that's like in design and build. Yeah.
Okay, thanks. I have a question from Discord. A member, how much storage can a single vertex node offer, and is it configurable?
So yeah, like it is configurable. So like in terms of vertex, well, sorry, and so like in terms of like participating in Swarm mainnet, all nodes have the same limitation, or well, not limitation, but they all offer the same amount of storage, or the doubling, with the doubling of the storage that is permitted in Swarm, in the redistribution game, and Swarm, in the redistribution game. So because Vertex operates within the Swarm mainnet environment and the Swarm mainnet specification, it's bound by the same. So that's the long story short. That's that part. But the way that Vertex is developed is Vertex takes all the Swarm parameters via a specification file, like very similar to the way that an Ethereum node takes a chain specification. Vertex accepts Swarm specifications. And Swarm specifications are things like, what is the size of the hash size? What is the size of a chunk? So chunks are, generally, the BMT body size is 4,096 bytes. You can set this to something that is a power of 2. So Vertex is actually well designed as well for if research want to tweak these figures and look at how the node would change and the behavior changes, and how this then like goes on to impact other protocols. So it's very good for like research.
Okay.
Or should be.
Very interesting. Okay, I'm not seeing any other questions in Discord, but also Elad, Callum, and anybody else, last chance round for questions. Otherwise, I already posted that link to this page where people can like have another look at what you've been actually walking us through right now, as well as the GitHub repository. Oh yeah, I haven't pasted that one in yet, but I will. Also, you are a very present member at Discord, so anybody can find MFW78 on Discord and ask any questions later on. Oh, I'm hearing a pludoop. Oh no, okay, but it's not really a question. So let's leave it at that, I suppose, and kind of follow up on the progress as we go along, because I mean, to me, it appears like there is some substantial road ahead of you developing this and bringing it to where you want it to be before it's fully shipped.
Yeah, well, I am somewhat hopeful to be able to have, I think, most really like storage nodes participating I want to say would be like maybe 2 months, give or take, like to allow for like, you know, testing. And like this is also like on the proviso that there's no like sudden crazy like changes with things. And like that's also 2 months like in terms of like man hours, not necessarily correlating to calendar months. So
not necessarily correlating to calendar months. Okay, that's a really cool phrase. But yeah, okay, even that, like, very nice to hear an approximate, or like at least an approximate ballpark of where this is going and how fast. Excellent to host you, and thank you very, very much for joining us, MFW78. This basically concludes our call for today. It's July. It's hot as hell where I am. It's late as hell where MFW is. And that's about it. So see you next month. Last Thursday of the month falls on 27th, I think. Yeah, let me check real quick. Yes, 27th of August is our next community call. And see you then. See you there. Bye-bye.